are solving word problems. And as I said yesterday, we did solve a couple of questions of word problem yesterday. And we looked at the different equations, right? We looked at the basic general equation, which is y equals a b to the power of x. And the other one that we looked at is the exponential one, also, which is a 1 plus I to the power of x. And that we'll use that when we have an exponential growth with a percentage, with a rate given to us. And then the other one, which is the exponential decay, 1 minus I to the power of x, again, when we have a rate. Okay? So these are the three equations that we're going to use. Now, with respect to the first one, y equals b to the power of x, that be sometimes we have the special cases, right? Where if it tells you that the thing or the number doubles, right? Then we know right away from that word doubles, we know right away that our base, which is the ratio, is 2, right? So it's doubling. Or when they say that the base or the numbers are half, or there's a half-life. This is where we have the base as a half. Okay? I'll talk a little bit more about these equations because there's the double and the half-life. They have their special little formula for them. We'll talk about these in a bit. Okay? But first, let's look at these examples. So the first example says a principal of $500 is invested at 8% per year compounded annually. Write an exponential equation to represent the relationship. Okay? So first, what formula do you want to use here?
The growth one?
The growth one with the 1 plus I, right? So I have to use the y equals a 1 plus I to the power of x. What is my initial amount?
500.
500. So I'm just showing you step by step here what you need to do. We don't need to show all these steps. We can put it all together, right? Now, sub in the common ratio. So in this case, there's different things. And we're using this formula because we picked this. So when these words here, for these words here, it doesn't show you, like, it uses this. Okay? That's why they have these cases here. But because we're using the actual formula that we should be using, we don't need to worry about this. But it's good to know. Double uses what number for the base? 2. Half-life uses half. Triple, what do you think is going to be? 3. Right? And then to convert, if you have a percentage, you're going to convert the percent to a decimal. And for growth, you're going to use 1 plus I. And for the decay, it's going to be 1 minus I, which we've already discussed that. So we're already starting with the actual formula. So what's my I?
That's 8%.
8%, which is what?
0.08.
0.08. So I have to plug that in. So it's going to be 500, 1 plus 0.08 to the power of x. And that is going to be 500, 1.08 to the power of s. Okay? So you see that ending up with this, right? If you look at this here, that looks like y equals ab to the power of x, correct? Right? Where a is 500, b is 1.08 to the power of x, right? So at the end, I'm going to end up with an equation that looks like y equals a b to the power of x. If I'm going to add to this question, what would I ask you? If I want to add part b, what would I ask you?
The decrease.
How much money would you have in the account after 7 years, right? I can answer this question, right? I can say, how much money would you have in the account after 7 years, right? What do you do if I ask you that? That's right. So you're going to replace x with 7, right? And then you do 500 times 1.08 to the power of 7, if I ask you that question.
Like the second example.
For B, it says a new car costs $20,000. its value is decreases by 16% per year after it is purchased. Write an exponential equation to represent the relationship.
The decay.
Which formula do I use? The decay, the negative one, right? Because I have the word decrease, right? So these are your key words. So you're gonna have to use 1 minus I to the power of x, right? So I have y equals, what's my initial value here? 20,000, right? So this is how much the car was worth when you bought it. What is I?
0.16.
0.16, yeah. So remember that you divide by 100, right, to find the decimal of the percent. So that's going to be 0.84 to the power of x, right? Does that make sense that it is between 0 and 1? That number is a 0.84. Does that make sense? Yes, because it's a decay, right? And anytime I have a decay, I have a number that is less or between 0 and 1. Right? And with this formula, you can kind of calculate how much will your car be worth after 5 years, after 7 years, after 10 years, whatever. Here's another typical exponential equation. So, any questions about the first two questions? Okay. So the population of Alberta between 1987 and 2005 can be modeled by an exponential equation. The population in 1987 was 2.4 million, and the growth rate was 1.7%. Write an equation to model the situation. Mm-hmm.
2.4 million.
Yeah.
And the growth rate, so I will use first formula of growth, 1 plus I. So 2.4 million.
Yeah, that's your initial.
Yeah.
So we're going to say that Y is population in million. Because when we find the answer, we need to be careful with that. Okay? And then we're going to say that X represents time. But time since what year? Because remember, my initial is not years, is not like when, like at the beginning of the planet, right? That's since 1987. So the time, X, is going to be the number of years from 1987. So 1987 is going to be my 0 year. Does that make sense to you? Because I'm starting with an initial value of 2.4 million in 1987. Okay? So that's time since 1987. Okay? So what would be 1988? What year would that be? Year 1. 1989 would be year 2. And so on and so forth. Okay? So for X, I won't be plugging in 1990 or 19 whatever, or 2000 whatever. For the X, I'm going to be plugging in how many years since 1987. Okay, so that's going to be Y equals 2.4. I'm not going to even write million because I've already said that Y is the population in millions. 1 plus 0.017 to the power of X. Okay, which can be simplified to Y equal 2.4, 1.017 to the power of X. Now, if you're trying to find your population in 1985, what would you do?
X equal negative 2.
X equals -2. And why is it -2?
Because 2 years before before the.
That's
addition.
right. So remember that 1987 is your year zero. Right? If you're going to 1985, that's 2 years before 1987, so that's going to be -2. Okay? So I'm looking at my population 2 years before my initial year. Okay? So I'm going to plug in -2 for x. Does that make sense to you guys?
Or if I go 1 minus 0.
Nope. No. Okay, what would be the, because you're not technically decreasing, right?
One,
You're,
is it this?
right? So what would be the answer for that? 2 point, did you put to the power of -7?
No, I switched the place. I put 1 over 1.017.
That's fine.
That's 2.3.
2.3.
Oh,
That's
okay.
what I got, 2.3. Okay, so because they gave it to me as 1 decimal place, I'm gonna leave it as 1 decimal place. Now what can you tell me? Because this is a word problem, you're gonna have to include a therefore statement, right? Therefore, the population in 1985 was 2.3 million. Remember that my population is in million.
Should we add this segment or can we skip it? Should we add the last part or can we skip it?
What do you mean?
To write the population was.
You have to, because it's a word problem,
Oh, okay.
right? Use your model to calculate the population in 2012.
X equal 25.
X equals 25. So to find x, you're going to have to subtract 2012 minus your initial population, which is 1987, right? And that's going to give you 25, right? And then you're going to plug in 25 in for x.
How can I do the exponent of 25 with the, if my calculator doesn't provide this?
This is your power button. You see this one? This is your
Oh,
power.
this one?
Yeah.
So 0.1.016. 7 like this.
Yep, to the power, yeah, 25.
Oh,
Yeah.
this side.
Times 2.4, what do you get?
1.5, no, still.
Multiply by 2.4.
3.6.
3.6, right? So assuming that there was no change in the rate and there was nothing going wrong,
Yeah.
right? The population in 2012 was, 2012, that's a fast for us, right? The population in 2012 was 3.6. half-life, they don't give it to us per year, okay? They say that that the population or the number of bacteria are doubling every 5 hours, right? So they have their special kind of like doubling time or half-life time or whatever like that. So a lot of times when we get these questions, right? So the formula becomes like this for the double and the half, for example, right? But it doesn't mean it doesn't work for the other equations as well. So I have a 2 to the power of x over d. So you see that this is for my doubling equations. Okay? Why do I know that this is doubling? Is because my base is 2. Okay? What you see different here is you see that your exponent is not just straight x. It's x over d, right? And that d is your doubling time. So how long does it take for the population or for whatever it is to double? Because usually it's not per day, or per year or per whatever, right? So that right here is your doubling time. And usually that's given to you in the question. Okay? So this example this would be an example for example, bacteria strand double every 6 hours. Okay? You have 10 bacteria count at midnight. How many bacteria will you have after 48 hours?
It means the A is equal 10?
Yeah. So your initial in this case, I know it's doubling because it says double, right? And it doubles every 6 hours. So if I'm going to start my equation, I have y equals a 2 to the power x over d. D is 6 because that's how long it takes for it to double. So every 6 hours, it's going to double. Okay? So what initial is 10 because that's my initial count. 2 to the power of x over 6. Okay? So that d, or that 6, is your doubling time. And that's what goes for d. Now the question is asking me, how many bacteria will you have after 48 hours?
So the Y.
So x is 48. Right? Y is the number of bacteria. So x is 48 over 6. Okay? So in this case, when you enter it in the calculator, make sure that when you put your power button, when you do this, right? When you put your power button, make sure you do the 48 divided by 6 in brackets. Okay? Especially if you have, like if you don't have the calculator that gives you the fraction.
Can you repeat? How can I do this?
So do your normal. So what do you do? 2
2,
to the power, open bracket.
this one.
48 divided by 6, close bracket. And then find the answer.
Multiply by 10.
Mhm.
Okay.
So how many bacteria did you have?
2,560.
this is increasing, right? Because it's doubling.
Decrease.
It will be half. What do you mean by increase?
Not increase, decrease.
What do you mean by decrease?
They found the solution or like anti.
But, yes, but that will be either, is it decreasing by a certain rate,
Okay.
or is it decreasing by half?
Yeah, it's like the same, but
Yeah.
I would say it will be decreased by, it's the same, but instead increase
It won't be decreasing by doubling. It will be decreasing by half,
half, yeah.
okay? So we're gonna look at an equation with half-life, right? And that would be, my equation for half-life would be very similar to the equation of the double, except my base is going to be a half. Okay? And that's going to be x over. Now, the letter that we used prior to that was D because it's doubling. In this case, we're going to use the letter H because it's half-life. Okay? It doesn't matter what letter you use as long as you know what each letter represents. Okay? So H is the half-life time. So again, similar idea. Okay? They found a solution for your bacteria, right? And now the bacteria, like you're killing half of them give me a number. You're killing half of the bacteria every 5 hours. Okay? So they found a solution for our bacteria count, okay? And the bacteria half-life is 5 hours, right? You started with 2,560 bacteria because that's what we just calculated, 48 hours when they discovered that you have that bacteria, right? So you started with, obviously the question will be set up much nicer than this, with 2,560 bacteria. How many bacteria will be left after 19? Okay? So what goes in for A? And it's half because I know the question says half-life, right? And then X over what goes in for H? 5, because its half-life is 5 hours. So every 5 hours you're going to lose half of them. What would I plug in for X? Because it's asking me how many bacteria will be left after 19 hours.
Oh, this question relates
Yeah,
to
I'm
the
just
first
relating
one.
it a little bit. Okay? What did you get? What? 183 bacteria? Almost.
Yeah, 183.
Yeah, it's the same, but I was not sure.
79.
About 184 because it's 0.8. Okay? So the thing is, with the half-life, and it could be with any of them, honestly, but say we use them with a half-life and the doubling, is where we have the half-life time and the doubling time, right? That are special, so we have to divide by them. So gave you extra questions also in your booklet. Our test is gonna be on Monday. So tomorrow is gonna be a review, and today you can finish working on your